Here's a quick video on handling exceptions or errors in Python. Suppose I ask you to make a calculator that basically divides two numbers, and you're supposed to ask the user for input. What you'll do is you'll say equals input, and then you'll say give A, and then B will be an input. You'll say give B, and then you'll say, okay, I'm going to print what A divided by B is. Right, and if you're not careful, you haven't put an integer or a float in here, so you're trying to divide the string version of A divided by the string version of B, and we know that that might cause issues here. Let's say this is 5, B is 10, but then you get a very particular error. And let's actually look at what the error means. It's saying that it's a type error, so something related to the data type of the variables you're using here on line 3. And it says that Python cannot support division, so the operator or the operand division, for two different strings. And we know the way to solve it is, of course, you surround your input function with integer, this constructor, and if you were to run this code again, let's do 5 and 10, and it gives you 0.5. Pretty awesome. Well, there's another way of handling this error, and let's use error or exception in this case. So there's another way of handling this exception, which could be to actually skip this line of code. So if the user gives you A and B and you didn't convert them into integers, how about you skip this line, skip this error entirely, and still continue running the code after this. So in that case, what we'll apply is something called exception handling. So I'm going to come up with a way to handle this exception, this error. And Python sort of allows you to do that built in. So what I will do is, just like an if-else statement, I will say try, and I'm going to indent this piece of code, and I'm going to say except, and I'll say print, there was an error. So what I'm saying to Python now is try to run this code. So after you execute lines 2 and 3, try to execute line 5. And if you're successful, then you can print A divided by B. If you're not successful, if you weren't able to execute this line without any errors, then print out that there was an error. Okay? I was just trying to see if I need to print something else. Let's do that. So let's do end of program, just to see what's going on. So if I were to run this program now, and you'll notice that I've removed the integers, so this is going to give us an error. Let's say 5 and 10. So Python, after lines 2 and 3, realizes that there are string numbers in A and B, and then it tries to execute line 5. When it fails, because it will in the backend have this error, and when it fails, it's not actually going to run it. It's going to say, okay, before I throw an error out to you, before I say that I cannot continue running because there is an error, I'm going to instead do this thing. I'm going to instead run line 7. So again, try to run line 5. If you are successful, then print whatever's happening. If you're unsuccessful, which means there was some sort of an error, then I want you to print this thing out. I want you to print, hey, there was an error. And then you'll notice that right after that, you still go ahead and continue with the rest of the code. Pretty cool. So we can fix this again by doing int, right? We can fix this. We know how to fix this particular error by doing something like this. And if I were to run this code now, and let's do 5 and 10, it will print 0.5, so it still tries to execute this piece of code. And if it's successful, it will, show it to me, and then it will not do this. So think of it like an if and an else. If this thing is successful, run this, don't run that. Otherwise, don't run this, instead run that. So now you're glad that you were able to fix this issue, but what would happen if I give 0 as B instead of 10? There was another error, right? But here's the problem. So this will basically give you a divide by 0 error, which is very much different from the type error that we had for when the integer function wasn't there. So there should be a way to handle different kinds of error differently. And that's where you want to write the name of the error that you want to handle in a different way. So by that I mean I can do except space. I'm going to say type error. That's the kind of error we get over here. And I will say there was an error in the handling of data type, right? So if I were to run this error shouldn't happen because we're converting everything to integers. But now if I do 10 and 0, you now get an error because Python said, okay, I'm going to try to do A divided by B and print it out to you, but I'm going to be on the lookout on just the type error. All the other errors, if they happen, I'm going to give it to you and I'm going to stop executing and I'm going to run line 8. And so in that case, we're going to have another except for the 0 division error. So I'm going to have 0 division error, and then I'll say, let's do this differently. Then I'll say, you cannot divide by 0, right? We can do something like this. So now let's run it. Let's do 5, B to be 0. And so because there was an exception here, Python said, okay, are you handling it though? And so it will check, is this a type error? It's not. Is this a 0 division error? It is. That's what we got earlier. And so it's going to run this line instead of actually executing line 5 here. So I really recommend that you try these exception handling out in your code for previous assignments, and don't just use try except and just run the code, but also have different types of except, so you're able to cater to different kinds of errors, and with different prompts, maybe with different sort of idea to tell to the user, hey, you got this wrong, not that wrong. That's where these different types of errors really thrive. So you're going to use exception handling potentially to bypass or fix or solve or all the exceptions that you might come across in Python. But they're all these kind of exceptions are under the umbrella of runtime exceptions, which means that your program is going to throw out an error or an exception when it's running. So think of it this way. You had no idea that the user will give you the value 0 for the number b, for this variable b. Only when you run the code and the user gives you the number 0 is when you're going to have an error here. Given the values 1 for a and 2 for b, there's not going to be any error. It's just going to give you 0.5. So an error that is introduced into the code as it's running is called a runtime error. And the only way you solve it or resolve it is by using exception handling. But on the other hand, if I were to remove this parentheses here, you'll notice that the input function has its own set of parentheses, but the int function only has an opening bracket, but not a closing one. Now this is a very different kind of error. It's not a runtime. It is in fact a syntax error. So syntax error is something that there's a problem with the code itself that you can look at, point to, and say, that's wrong. That line there is wrong. And so you can fix this by actually correcting the mistake you made. So let's say I did something like this. I do this. Well, Python will say that's a syntax error because you cannot assign a function a value, right? You can assign the value returned from a function to a variable, but not the other way around. This should be over here on this side of the equal sign, and this should be on the other side. So in this case, this is also a syntax error. And how do you resolve it? Not through exception handling, but by saying, oh, I'm just going to fix the code. I'm going to say it's b equals the int function. So two different kinds of exceptions in Python. You have syntax errors, you have runtime errors, and exception handling can only be used to solve or bypass runtime errors only.